Hi there, RStudio friends, and welcome back to my YouTube channel, which is about RStudio coding and some cool things that you can do in RStudio. If you've been following along with any of my previous videos, I hope they've been beneficial to you in some way. Maybe they've helped you out with a specific problem that you were having, specific task. One of the important takeaways from any of my sessions is explore different libraries. We will use a couple of libraries in this session to investigate models a little bit further. A couple of the really cool ones for models, useful ones, are ggplot and ggstatsplot. And that's because both of these allow you to get graphics, make visualizations that show model results, okay, such as p-values. ggstatsplot also allows you to get means for different levels. And remember that the ultimate goal of an ANOVA or a linear model is to see if there's a difference between different levels of the predictor or predictors on the response column, i.e. does the response vary with changes in the predictor, in the levels of the predictor. Words that we use for those different levels can also be groups, okay? And this is a really useful library that we didn't do too much on, but one of the good things about it is that you can also show results of parametric and non-parametric tests. If you want to remind yourself of the difference, it really comes down to if assumptions are met or violated. And you also use non-parametric for very small data sets. But remember that non-parametric is less powerful than parametric testing. You can go back to a previous video to find out more about that. What we really wanted to talk about today is relevel function, okay? And when would you use the relevel function? Okay, so that's in order to choose specifically what you want your baseline level or baseline group of a predictor to be, okay? Which is useful to set that, for a model. In linear modeling, if you use LM, okay, you'll get results in the summary output that compare the estimates against whatever is the baseline. And if you don't set anything as a baseline, it's just going to take the first group alphabetically or numerically. Let's use a data frame to look more into this. Okay, this is a data frame that's currently in Tidyverse, diamonds. And guys, I can't remember if we've already used diamonds, but it is a very useful data frame for exploring graphics, models, whatever. It's a big data frame though. 54,000 rows, 10 columns. I feel like we have looked at this, so I won't spend too much time on explaining it, but the idea is that the main response column in this data frame is the price of each individual diamond. There's 54,000 diamonds. And all the other columns are information on the features of those diamonds. So you might want to make a model to see how does the color affect the price, how does the depth affect the price, how does the cut affect the price, or maybe a combination of all of those. But we're going to keep it simple today because we're just going to choose a categorical predictor, this case color. Okay, so we would make a model, an LM model. We could also make an ANOVA. Okay, the results would be very similar. And this model would look at the how do the different levels of the color affect the price. Notice that these colors are D to J. I've never heard of the color J, so it must be some sort of code. But if we do an str of the diamonds data frame, this will tell us the data types. And we're looking for words factor, okay? Factor for anything like that, okay? Yeah, ordinal factor. There's 3 ordinal factor columns. And we're going to make a model of how does the color affect the price. I won't do anything to change the baseline yet, which means it's when it shows results in the summary, it will compare against D, okay, which is the first alphabetically. We might not want D to be the baseline level, and that's where we would use relevel to choose the baseline ourselves. Remember, it chooses the first alphabetically. So the summary output will make a comparison, E to D, F to D, G to D, etc. If we want to get different results from summary, we can change the baseline. And if you've got okay, imagine you've got a data frame that has information about a medicine, okay, and you want to compare against an existing medicine. Maybe that medicine, this existing medicine, begins with the letter C, but then you've also got a new medicine that begins with letter A and letter B. By default, the summary code will compare the A to the C1 and the B to the C1. It will compare the C to the A, okay, and it will compare B to A. That might be wrong because it's actually the C1 that should be chosen as a baseline, not the A1. So we would want to change that ourselves. Let's make a model first of this effective color on price. I'm not going to work with 54,000 rows because ggplot might have a problem with that. So let's filter the data frame first. And you'll remember we talked about filtering in a previous session. You make a copy of diamonds and you apply the pipe function to filter. Okay, you're going to filter the column of interest. That's the color column. Remember, this name of the column there needs to be spelled exactly as it is here. So even though we're British, I'm not British, I'm Scottish, we don't put a U in there. Okay, we don't actually want to filter. We don't want to filter the color column. We want to filter something else. We want to filter the cut column because I'm trying to cut this data frame down from 54,000 to something much smaller, okay, to be able to work with. I know from past experience that the fair column, the fair values here, the fair rows, there's only 1,000 or something of them. So let's put cut equals fair just to get a smaller data frame, okay? And we can then view that new data frame, which is diamonds 2, and we can confirm that it's much smaller than the original, 1,600, okay? Now that means that we're left with only fair in the cut column, and if you're writing a paper you should definitely mention that. But we still have a lot of options, okay, in the colors now. Let's see if all of the colors still remain. Okay, color D, E, F, G, H, I, J were good. So we've still got all the colors of interest, but we have a much smaller data frame. Now we can make a model. LM model, okay, is back arrow of LM, data equals, remember this is just 1 equals sign, not 2 like over here, okay, and we put diamonds 2. Then we choose the response column spelled exactly as it is in the data, that's the price column here, and we put the predictor here, color. Okay, now there's a couple of things that you want to make sure exist at this point, okay? Options scipen equals 999 will show the results of the summary, the p-values, as decimals instead of e to the power of, which helps a lot with understanding them because you want to compare typically against 0.05, but not always. Okay, I'm expecting something strange to happen now, okay? If we do summary of LM model, yeah. There's something strange going on in RStudio with this data frame and this column in particular. We don't have any LQC456, but it's told us that we do. And I'm not sure why that is if it's like a glitch. So I'll show you how to get rid of that and turn them into to this strange problem where we've got these strange colours that don't exist. Okay. A lot of people might spend some time trying to figure out what's going on here, but there is a way to fix it. Okay. We're going to first convert it into character and then back to factor. Again, I don't know why you want to do that. So you're working, of course, with the diamonds 2. As a reminder, this is a change in the data itself, not in the model. Okay. So we can put it here before we even make the model. Okay. And we use old school base R code. Diamonds 2 $ color. We're referring to the color column. Back arrow is your friend here. And we're going to copy everything that we just wrote here, paste it on the right as well. And I've shown you how to turn things into factors before. Imagine you've got like numbers that should be treated as groups instead of, you know, the numbers themselves. You would use that. But we turn it first into a character. And if you do that, then run an str on the diamonds 2, you'll see that something changed. It's now chr for character next to color. Okay. Then after doing that, we just copy this, paste it again, but change the word character to factor. And we'll put that here, factor. Okay, then run the str one more time, and we've now got the word factor here. Okay, we can't be sure at this point that it's actually worked until we run the model again, but it has. So guys, there's one letter, there's one group color that's missing here, and that's D. Okay, that's because each of these is being compared against D. Color E is being compared against D. Color F is being compared against D, etc., etc. D is the intercept, corresponds to the intercept. And then we have a p-value that shows the difference, like whether there's a significant effect or not, you know, in the price between E and D or F and D. For the reasons I explained earlier, there might be some real advantage in changing to a different color for your baseline to get changes in these results here. So this is very simple code, and it's base R code again. Okay, actually we can just copy this, and we just put diamonds 2 color, change this to relevel. Okay, there's one more thing we need to do within the brackets. We put ref equals, and here you define what you want your baseline to be. Reference means a baseline. Let's choose F. This would still work if you took out ref equals and just wrote F in quotation marks. Okay, to check that it's worked, we just write levels brackets diamonds 2 $ color. You'll be very familiar with the $ now for these changes in the levels, baselines, factors, change in data types, etc. And now you see that F is mentioned first, and that's because it's set as a baseline. I'm going to now copy and paste the code below, and we'll run we'll run a model again with that new baseline. Okay, so this is the baseline equals D, and this new one is baseline equals F. Okay, so we probably want to call this model LM model F. Okay, and see if anything changes. Right, so now F is missing, and we have everything being compared to F. Obviously, a quick comparison should show that you have different results. Okay, And so that's why it's crucial to define what your baseline is. Don't choose the one automatically that's first alphabetically if it doesn't make sense to. Set your baseline using relevel. And now for like a quick final thing, let's just make a parametric plot. I'm not suggesting that parametric plot is the best way to go, and if you want to know the better way to do it is look at the residuals. Okay, but assuming that we do want to go the parametric method, let's write some code for making a nice graph with p-values on it, and p-values will be an important feature in this graph. Okay, so we've got the library loaded. Again, it's this one, ggstatsplot, but we start with gg between stats to compare the groups. Gg between stats. Then the code in the brackets is similar to ggplot. There's no AES part, but the rest is kind of similar, and we're using diamonds 2. Here we put y equals price, x equals color, and there's just one more thing we need to add, which is the type of models that we want to run, that we want to show the results of on the graph. And obviously LM is parametric and ANOVA is parametric, so let's go that road. So parametric, and running this should show a nice little graph for us in the plots tab. Yeah, wow. Oh, that's colourful, huh? That is colourful. Now what I like about this is a couple of things. The means being shown here. We also have the P's. The P's are not shown for every single color pair, okay? We have the P for the entire model, and the graphs are plotting the data as well as the mean, okay, being the red circles, the mean price for each color. And we also have the box plots, which show the median line in the middle, the box plot. One thing I don't really like about the results from this is they are again in e to the power of minus something, and so it's difficult to compare that with the summary results or this number, which is the p-value of the entire model. I'd like to edit this to turn them into decimals. But this is nice, and don't forget again that analysis, variance, and LM is comparing the means. Okay, if we turn this into non-parametric, let's just see how the graph changes. You'll notice that different types of tests are being shown. Kruskal-Wallis is being shown here. Okay, and it doesn't show means anymore, it shows the medians, which we already had. That's why the red circle falls onto the middle lines of the box plots. Remind yourself of why we should use non-parametric versus parametric. Residuals are the key answer to this. And so we get a lot of information from this, okay, that we actually, once it's sorted with the decimals, combine results of summary code as well as any graph stuff that we could have made in ggplot into a nice single graph. I'm going to leave it there now, and there's so much more that you can do with turning this results into a nicer display, either table or graphic. With analysis of variance as well, I would never stop after just doing an ANOVA. I'd do a Tukey test to do pairwise comparisons of every single pair. When you have it like that in an ANOVA model, you could compare F with D, D to E, D to G, H to E, every single pair combination that exists, you can do with Tukey. I think we did Tukey before. It's really the way to go if you figure out that the entire ANOVA is significant, okay? And then you can see where the significance lies. So the next time I will show you some extra facet wrap stuff, I want to emphasize that facet wrap is now my kind of go-to instead of doing color and stuff on plots. I was talking about this with somebody. When you publish papers, sometimes the publication doesn't allow you to publish in color, or doesn't want you to. They want you to have it in black and white. If you do facet panels, you can add all the labels to the headers, but you might not like the default facet wrap. There's extra edits and libraries you can use to make the facets look nicer. So I'm going to leave it there. I hope you have a good day. I hope this is able to help you. Please message me below if it's helpful and what you'd like me to do next. Bye.